Welcome, I'm Kevin King. In this, the second of our series of 6 training videos, I will introduce our Inter-Row guidance system hardware and some of the hardware options that are available. Other videos in this series take you all the way from how our systems work through to creating configuration files for crop or machine geometries that you've not already got stored preset configurations for. You can select the video you need from our website and view it as many times as you want. The same material is covered in rather more detail in our reference manuals, which can be also downloaded from our website. The Inter-Row reference manual is available in English, French, Spanish and German languages. This schematic depicts a single section Inter-Row system, with some of the standard options. At its core is the implement module to which all peripheral devices are connected. Power is connected via this connector and should be supplied using a suitably fused 12-volt power connection, usually a tractor D-plug or similar auxiliary power outlet. The console provides a user interface via a touchscreen display and also houses the main computer running the image analysis and tracking algorithms. 12-volt power and gigabit communication between the console and implement module is supplied via a single cable connection. Cameras are also connected by Gigabit Ethernet. One camera is all that is needed for many applications, but a second socket is fitted as standard, making a second camera simple to fit. Additional cameras requiring additional sockets can be fitted by special request. Cameras are powered using power over Ethernet, allowing a neat single cable connection. Other connected devices include position sensors, for example to measure side shift position and in or out of work position. These are colour-coded blue and red respectively. There is also a speed input using the yellow port, but many of our systems utilise alternative speed sources, such as isobus or visual odometry, where forward speed is estimated by the cameras, so is often left unconnected. Directional valves for control of hydraulic steering cylinders, as well as the facility for connecting night operation lights, are connected using this connector. A CAN bus data socket connects to a variety of our proprietary accessory devices. For Inter-Row applications, these are most commonly manual or feeler override boxes. We also have the option for connecting to isobus. This connection can be used to utilise tractor hitch position and forward speed, as well as other tractor-related information available on the tractor bus. The implement module looks very similar and retains almost all connectors when compared to the non-isobus version. Lift and odometer inputs are usually disconnected when using isobus, but are available as backup inputs for when connecting to a non-isobus connected tractor. The module power cable has been replaced by a panel mount 12-volt and communication port. The implement is connected to the tractor's isobus socket using a single 12-volt power and data connection cable. If you wish to control 2 independent implement sections from a single console, you can plug in a second module to control that additional section. All parts are the same, except the implement modules are modified slightly to make master and slave versions. Again, we use point-to-point cabling to cater for all machine sizes and to make service simpler. An optional anti-clash interlock prevents 2 sections from colliding. Dual section systems facilitate higher working rates and are becoming more popular. Similarly, you can follow 3 independently planted belts with a triple section system that uses a master module with 2 slaves. The 3 sections can be all rear mounted, all front mounted, or a split with the centre section on the front and the outer sections on the rear of the tractor. This is a particularly nice configuration from a vision guidance perspective, as it gives a totally unobstructed view for all cameras, thus providing the best possible performance. Let's take a closer look at some of the components individually now. Starting with the console, it has a 9-inch colour touch screen, behind which sits a small but very powerful PC, running our image analysis and plant tracking software. It is housed in a machined aluminium case, with sockets for connection to the implement module and a USB stick through which software can be updated or data exchanged. There is also a power button. All of these components are sealed into the case, which is showerproof but intended for mounting within a tractor cabin. The vison mounting holes at the back will accommodate a variety of mounting arrangements, but we recommend ram mounts or similar as they are convenient and provide a degree of vibration isolation. The camera is mounted within an aluminium casing with O-ring seals specifically designed for the agricultural environment. However, they will not withstand pressure washing, and it is prudent to store them under cover, especially during the winter. We offer two types of camera, being the standard RGB colour camera, which is the most common and suitable for almost all applications. But for trickier specialist situations that require the operator to frequently use custom colour when using a standard colour camera, we offer an alternative camera type with sensitivity in the near infrared and detects a combination of colour and reflected infrared from plant foliage, making oddly coloured crops much easier to track. This camera type is auto-recognised and can be set up and operated in the usual way. Contact Tillett and Hague for more information on this camera type. There are no user serviceable parts inside the camera, and it is important that the seals are not broken as moisture ingress will lead to misting inside the camera glass cover and will degrade the electronic components inside. We offer all our cameras with two lens options, 6mm as standard for normal intro applications and a wider angle 4mm lens for special applications, where the camera cannot be mounted sufficiently high to get the required field of view. The lens type is shown on the label, but lens data is programmed into the camera so that it will be automatically recognised by our system and the correct parameters used. The camera has two M6 mounting holes machined either side of the case. We also offer a camera bracket which offers a convenient way of adjusting camera inclination. When working in low sunlight conditions, cameras can sometimes benefit from the installation of our retrofit shading hood. This shading hood is available from Tillett and Hague as a 3D printed component, or on request we can provide customers with a 3D print file along with suggested print settings to try the hood for themselves. The hood is affixed to the camera using the two unused M6 mounting holes. The hood is available in two variants, depending on the camera lens type to which it is to be fitted. The implement module is also nominally waterproof, but is sealed to a lower standard than the cameras, so we recommend that it is housed under a covering that protects it from direct rain or cleaning jets. Tillett and Hague can also provide and fit a pair of implement module mounting brackets that allow easier installation of the implement module, and also not requiring the enclosure to be opened by the OEM manufacturer during installation of the module. System 12V power comes into the module on a short flying lead with a 2-pin connector. In the case of an Isobus connected implement module, the 12V power lead is replaced with a power and data socket for connection to the tractor. All other connections are identical in operation and function. An LED power indicator provides system status information via blink codes. On power up, it is continuously on for a few seconds before going into a slow 1.5 second blink indicating it is running but idle. Once the working screen is displayed, the blinks speed up to a very rapid but even blink. Other blink patterns are associated with error codes that are listed in the reference manual available from our website. The module has a number of sockets as previously described for connection to the console, camera, CAN bus and valve connections. Lift, position and odometer sensor inputs and cables are colour coded. The external label provides a graphical description of connector functions. There is also an internal lid label providing more information on internal connections and settings, though it's not normally necessary to remove the lid. Most cables have connectors at both ends so can be easily swapped out in the event of damage. They are also available in a range of lengths, making installations neater and safer. Here we have a camera cable, a console cable and a power cable. We have various Isobus cabling available to suit implement mounting, and also an Isobus splitter allowing a Tillett and Hague Isobus configured guidance system to be used in conjunction with another Isobus connected implement. Our system could accommodate a wide range of sensors for measuring linear or rotary movement, as well as proximity detectors or switches. We also stock compatible sensors ourselves for those who wish to purchase a complete package. We are also happy to work with customers who provide their own sensors, though it is prudent to check for sensor and system compatibility with us. We can interface with most position sensors fitted within hydraulic cylinders, for example. Where customers wish to supply their own sensors, we can in most cases provide compatible sensor connection cables. As an alternative to using your own sensors to detect lift or measure speed, we also offer a cable to connect the module inputs to a tractor 7-pin ISO 11786 socket located in the tractor cabin. Note that it is often a very neat solution, but be aware that not all tractors have that socket available. Almost all our systems are used in applications requiring control of hydraulic valves. In most cases, these are on-off directional valves that require some sort of additional flow control mechanism to preset the rate of movement. We also support proportional valves that control both the direction and the rate of movement, though at the cost of tighter oil quality requirements and a higher purchase cost. Customers are also welcome to provide their own hydraulic circuits, customised to their own needs, but we do offer generic valve blocks incorporating flow control and circuit pressure adjustment in our non-proportional assembly, and a high-pressure inline filter assembly supplied with our proportional valve block assembly that are suitable for most applications. The valve output socket also includes an additional configurable output. Standard valve looms leave that additional output unconnected, but on request, valve looms can be provided with that auxiliary output included. By default, that output is set to be off 0 volts when stationary and then on 12 volts when moving. This can be useful in band spraying applications to trigger a pump relay, for example. Alternatively, that output can be configured to operate night operation working lights that can be switched on and off from the console working screen. These options are available as standard and can be implemented for the cost of the additional components. As mentioned earlier, we communicate between some auxiliary devices and the main implement module via our own proprietary CAN bus protocol. These devices are automatically detected and will be available for use during normal running. The manual control box, when switched to manual, allows a user, either the driver or a second operator, to manually steer the implement. Switching it off returns to automatic guidance. The feeler guidance box is electrically very similar to the manual box, except that it receives inputs from proximity detectors that should be positioned to detect the movement of feelers or whiskers set up within the canopy so that they are deflected when the implement is out of position. Its exact behaviour is configurable. Note that it is possible to combine feeler and manual override devices by linking them together into a single assembly. A permanent cable gland connection connects the manual override to the feeler input device, with the feeler device then connecting to the implement module proprietary CAN bus connector. Okay, so that's been a quick run through of our Intero system hardware. We pride ourselves on the flexibility of our system. It is modular and designed with robustness and serviceability in mind. Point-to-point cables provide neat serviceable installations. We offer a wide range of sensing options and can control a wide range of outputs. Our CAN bus for auxiliary functions adds to our capabilities. And Isobus connectivity allows for simpler installation and operation. Additional cameras are easy to connect and in an affordable way. Our modular architecture easily facilitates multi-section machines, further enhancing performance potential. We hope that you have found this presentation useful. Remember that it is part of a series of 6 videos that you can select from our website and view them as many times as you want. Our website also has links to other reference and training material, including full reference manuals in a variety of languages. If you have any questions, please get in touch. Thanks for watching.